quick factoring that you probably, I know that you learned in Algebra 1. So let's just do this do now real quick. Oh, sorry. The title for today's lesson is Factoring Trinomials. So my directions are just to factor. Okay, so I will give you a couple of minutes to factor these 6 problems. Ariana, who's usually next to you? Do we know who's usually there? Who's usually next to you? Anybody? Okay, thank you. Okay, let's go over this. So remember, when you're factoring, you're essentially working backwards. So what's happened is I've given you the product of something and I'm asking you what 2 things multiplied, what 2 expressions multiplied to this product. The way you do that is we set up a double set of parentheses to show multiplication. And because we're trying to multiply to x squared, we put an x and an x in the front. And then we need 2 numbers that multiply to the last number, but add to the middle number. So I need 2 numbers that multiply to a positive 6, but add to a positive 5. Ira? You got it. So if I have an x plus 3, if we do 3 and 2, 3 times 2 is 6. 3 plus 2 is a positive 5. So those are our winners. You write those numbers inside your parentheses using the same signs. So it's x plus 3, x plus 2. And who remembers how to check to make sure you factored correctly? Amanda? Exactly. Anytime we're factoring, if you want to check it, you just FOIL back. So I'm just going to write this over here and then I'll erase it. If I have x plus 2 times the quantity of x plus 3 times the quantity of x plus 2, we FOIL it back. We're going to get x times x is x squared, x times 2 is a 2x, 3 times x is a 3x, 3 times 2 is 6. So we end up with x squared plus 5x plus 6. Was that the same as the original problem I asked you to FOIL? Yes, which means, factor, which means we did it correctly. Okay, who factored the second one? Next to Lily is, what's your name? Angid. You got it, x minus 3 and an x minus 2. This is because we need to multiply to a positive 6 and add to a negative 5. So a negative 3 times a negative 3 is a positive 6. A negative 3 plus a negative 3 is a negative 5. Perfect. Okay, what about number 3? X squared plus 5x minus 6. What's your name? Micah. X plus 6. Perfect. Now we've changed the factors completely. X plus 6 times an x minus 1. 6 times a negative 1 is a negative 6. 6 plus a negative 1 is a positive 5. All right, x squared minus 5x minus 3. What do we get for this one? What's your name? Anishka. X minus 6 and an x plus 1. Negative 6 times a positive 1 is a negative 6. Negative 6 plus a positive 1 is a negative 5. All right, how does number 5 visibly look different than the other 4 problems we just did? How is it different? How does it look different? Ariana? There's no middle term. This is only 2 terms. Everything else was factoring a trinomial. This is factoring a binomial. And when it comes down to a binomial, our only option for factoring is a dots. Well, actually, before we do anything, does anybody know what we always look for no matter what first, even though it's not in any of these problems? What's the first thing when we're factoring that we always look to see if there is? Amanda? A GCF. So that still stands. We always look for a GCF first. None of these problems had a GCF. So we look at number 5 and we see, okay, well, there's no GCF and this is a binomial, not a trinomial. The only way to factor this would be if it were a dots. Difference of 2 perfect squares. That's what I call a dots. Difference of 2 perfect squares. Who remembers how to factor a dots? What's your name? I'm sorry? Anish.
So we would like to get the square, x squared,
Mm-hmm.
and then the square 9, which is 3. And we do 1 for plus and 1 for minus.
You got it. So the way we factor dots is essentially we take the square root of the first term. So square root of x squared is xx. That goes in the beginning of each parenthesis. Then we take the square root of the last term, which is 9 square root of 9 is 3. And you do 1 plus and 1 minus to get that negative in the middle. Just to show you when we FOIL this out, we're going to get x squared minus 3x plus 3x minus 9. What's a negative 3x and a positive 3x? 0. So isn't that x squared minus 9? So that's a dots. What does dots stand for again? I had just said it. What does that stand for? Is it Philip? No. Yes? Okay. Good. Difference of 2 perfect squares. What does difference mean, Charlie? Subtraction. So in order for it to be a dots, you need 2 perfect squares and a subtraction sign. In number 6, do we have 2 perfect squares? Yes. But do we have a difference? Do we have a subtraction? No. So this is already factored. This is as factored as it goes. We cannot factor any further. So it's just x squared plus 16. There's nothing we can do there. So this do now was the most basic version of factoring. Let's do some more problems. So I'm going to say to factor, I'm going to put a star. I'm going to say always look for GCF first. So in number one, is there a GCF here? There absolutely is. What factor is in all of these terms, Ira? A 2. So what we're going to do is we're going to pull out a GCF of 2, and then we go back and we divide everything by that 2. So it's y squared plus y minus 30. And now we factor what's left inside the parentheses. So somebody tell me, what are factors of negative 30 that add to a positive 1? Anish? You got it, a positive 6 and a negative 5. That GCF is part of your answer. So if you just divide out the 2, but then you forget to put the 2 in front of the parentheses, you're going to get points off because that 2 is part of the answer. Because if I were just to FOIL out y plus 6 and y minus 5, I wouldn't get the 2y squared plus 2y minus 60. I would get the y squared plus y minus 30. You then have to distribute in that 2 to get your beginning quadratic. Okay, next one. Okay, is there a GCF? No. So this is factoring with a leading coefficient. Now, when you're factoring with a leading coefficient, if you had 5 different teachers, every teacher would have showed you to factor this a different way. Some of the teachers use the earmuffs where you multiply the first and the last. How many teachers taught you that way? Okay, I know earmuffs. I can, if you forgot how to do earmuffs, I could refresh your memory on earmuffs. Some teachers do some kind of X thing. How many teachers taught that X thing? I don't know the X thing, so I can't help you with the X thing. I basically just like to show the guess and check, which is more of just common sensing your way through it. So that's what I'm going to show. If you need me to refresh your memory on earmuffs, I can. Unfortunately, I can't refresh your memories on the X. So for this, what we want to do is we want to set up our double set of parentheses. And in the front of each parenthesis, we want to think of what multiplies to that first term. And if it's if the coefficient is prime, it's really easy because what's the only thing, 2 things that multiply to 3x squared? A 3x and an x. There's not really options there. And now what we want to do is we're still looking at that last number, and I'm going to look at factors of a positive 5. Factors of a positive 5 are either both positive or both negative. Do we agree? All right, so let's not worry about both positive or both negative right now. The only factors of positive 5 are positive 5 and positive 1 or negative 5 and negative 1. Do we agree? There's no other factors. So this is where the guess and check comes in. Now we have to put either positive 5 and positive 1 inside the parentheses, or we have to put negative 1 and negative 5 in the parentheses. But keep in mind, when we FOIL it back out, I have to add to a negative 8x. The middle terms have to add to a negative 8x. If everything is positive, will we ever add to a negative? So what do you think is going to happen? Both signs should be negative. So I say this is sort of guess and check, but you're rationalizing your way through it. So now, when we FOIL back out, when we get to that middle term, the way we check the middle term is the first term will multiply with whatever's here. And this number will multiply with whatever's here. That's how we get the x terms. So now I need to add to a negative 8. If I put the, oh gosh, hopefully it's still recording. Yes, it is. Good thing. All right. So if I put the 5 here, I would have to multiply the 3x times 5. And what will that give me? 15. And then I would just have a 1 and an x. Can a 15 and a 1 ever give me an 8? No. So then my other option is to put the 5 here and the 1 here. Let's see if that makes more sense. If I put the 5 here and the 1 here, let's try that out. Let's check this. 3x times 1 is 3x. Negative 5 times x is a, oh, sorry, negative 3x. Negative 5 times x is a negative 5x. Negative 3x minus 5x is a negative 8x. Is that middle term good? Yes, that's how we know we factored this correctly. So this is my rationalizing your way through guess and check. Is our factored version. Does anybody want me to show them earmuffs? Okay, so if you did not learn earmuffs, this is so confusing. If I were you, I'd turn off your brains, because unless you learned it and practiced it all of Algebra 1, you're going to be completely lost by it. So the way earmuffs works, I'm going to do the same problem. So the way earmuffs works is you take your first number and your last number, including the sign, and you multiply them. So you're going to get 3 times a positive 5, which gives us a positive 15. Then, and now your teacher might have written this differently, but it's essentially the same concept here. Then what you do is you're going to ask yourself, okay, well, now I need factors of a positive 15 that add to a negative 8. What are factors of a positive 15 that add to negative 8? Negative 5 and negative 3. Every student loves this up until this part, but they don't realize if you don't do this next part, you get it wrong. The next part is now you're going to take that first number and variable, that 3x, and you're going to divide both those numbers that you guessed by that first number and variable and try to simplify. Can I simplify a negative 5 and 3? Can I reduce that? No. Can I reduce a negative 3 and a positive 3? Yes. So I can reduce the second one. 3 goes into 3 once, 3 goes into negative 3, negative 1 times. So now when you go to make your parentheses, you write your parenthesis from bottom to top. So from bottom to top, this is a 3x and a negative 5. From bottom to top, this is an x and a negative 1. It's the same, right? That's just earmuffs. It's a twist on like factor by grouping. Oh, that was another way. Did anybody also teach factor by grouping, their teacher? Okay, this is a twist on factor by grouping. It's just like a manipulation of it. It's odd though, I know. Okay, let's do more. Yes. AC is earmuffs. Yeah. Okay, next one. 24x squared minus 16x minus 30. What's the first thing we always look for? GCF. There is a GCF here. Unfortunately, it's not 24 because 24 would be nice. Why would 24 as a GCF be nice? Ariana? Good, because then we wouldn't have to worry about a leading coefficient. Unfortunately, that's not the case, but we still have to pull out that GCF. What is our GCF here? 2. So we pull out a 2, and we get 12x squared minus 8x minus 15. What you guys chatting about back there? I don't know. You were smiling, Leo. Math wouldn't make you smile. You really like it. You really love math. You feel so passionate about it. Okay. All right. So here we have 12x squared minus 8x minus 15. Unfortunately, we didn't get rid of that leading coefficient. It's still there. So now you factor. You factor however you learned. If you factored through the x, use the x. If you factored through grouping, use the factor through grouping. If you factored through earmuffs, use earmuffs. If you don't know, let's go through, guess and check and rationalize our way through. So what I'm going to do here is this one's a little bit more difficult. Why is this one a little bit more difficult? Because 12 is not a prime number. So 12 has multiple factors. So we can do 2 and 6, or we can do 3 and 4, or we can do 12 and 1. Do we agree? Factors of 12. All right, and then we also have to look at factors of negative 15. Now, when we're looking at factors of negative 15, there's no choice here. Last time we had a choice. They could both be positive or they both could be negative. We know for certain one has to be positive and one has to be negative. Do we agree? Now, I don't know which one is positive, which one is negative, but factors of negative 15, we can do 15 times 1. We can do 3 times 5. Obviously, one of them being positive, one being negative. No other factors of 15. So this is where the guess and check part comes in. Let's start with the factors of 12. Which one do you want to start with? Should we start with the 2 and the 6? Okay, let's start with the 2 and the 6. So we're going to have 2x and 6x. And now we're going to guess and check this. So we're going to do 2 multiplied with the number here, and we're going to do the number here multiplied with the 6x. Let's start off with 15 and 1, just to show you. So let's say I put, well, first of all, I know 15 can't go there. Right off the bat. I know no matter what, even if 15 and 1 are my answers, I know 15 cannot go there. Because if I put 15 in here, isn't there a GCF? 6x and 15, isn't 3 a GCF of that? So right now, I can't have factors that have a GCF in it. I already pulled out the GCF. So that will never work. Your factor will never make another GCF happen. Does that make sense? What I'm saying? Okay, so I know for certain there's no way 15 can go there. So now we're going to say, okay, 15 will go here and 1 will go here. Let's check. And we need 1 negative and 1 positive. I'm going to go with negative 15 and positive 1. All right, so we have 2x times 1 is a 2x. Negative 15 times 6 is a negative, is that 90. Will a 2x and a 90x ever give us 8? Never. So we know 15 and 1 is out. 15 and 1 is out. What does that bring us to? My only other option is 3 and 5. Why can I not put the 3 here? Why is that not allowed? Only Ariana knows. Why can I not put the 3 there? I know for certain. Charlie? because then there would be a GCF and we can't do that. So the 3 definitely can't go there, which means the 3 has to go here and the 5 here. I'll worry about the signs later. So let's do 2x times 5 is 10x. 3 times 6x is 18x. Is there a version of 10x and 18x that can give us a negative 8x? Yeah. Which one would have to be negative? The 18 would have to be negative. Since the 18 would have to be negative, that means this 3 has to be negative because that's what got us that 18x. So if the 18 is negative, that means the 10 has to be positive. So this is a plus. And now we have our winner. So it's going to be 2 times the quantity of 2x minus 3 times the quantity of 6x plus 5. Now, the problem with earmuffs or the AC method is that sometimes you end up with numbers really big. So if you did earmuffs here, you do 12 times 15, that's 180. So it's still doable. It just might take a little bit longer for you to figure out your numbers if the numbers are on the larger side. All right, next one.
If you do it to number sense, you're gonna show your work like all the
No, that was just me showing. Yeah. If you could do it in your head, that's wonderful. And I would prefer that. Okay. So this is a little bit different. I have a variable in the exponent. So what I'm going to do, I'm going to make sure that this is factorable. And the way you make sure that it's factorable is if the first exponent is double the second one, that means it can still be factorable. So is 2m double m? Yeah, so that means we can still factor. And if you prefer, we can use substitution. So what I'm going to do is I'm going to let I'm going to let a equal x to the m. Well, if a is x to the m, what's x to the 2m? A what? A squared. So here we're going to have 6a squared plus 19a plus 15. Any GCF? No GCF. So we got a factor. Factors of 6a squared, you could either do 2 and 3 or 6 and 1. Let's go with the 2 and 3. So I'm going to have 2a and 3a. Do we agree that everything has to be positive since we're multiplying to a positive and adding to a positive? So I can right away put plus and plus. And now I need factors of 15 that when I check this, give me 19a in the middle. So there aren't many factors of 15. Some factors of 15 are 1 and 15 and 3 and 5. Which one do you want to start with? Okay, perfect. Can I put the 3 here? No, because that makes a GCF. So I can't put the 3 there, which tells me the 3 would have to go here and the 5 here. Do we all agree? Now let's check that. 2a times 5 is a 10a. 3 times 3a is a 9a. 10a plus 9a, 19a. We found our winners right away. So now we have 2a plus 3 and 3a plus 5. A lot of students do all the hard part like this, did all the hard part, and then leave their answer like this. Why can't I leave my answer like this? Anishka? Yeah, I use substitution, so now I have to substitute back. Remember, a is x to the m. So this is going to be 2x to the m plus 3 and 3x to the m plus 5. Mm-hmm.
I use earmuffs, but like I have to go on and super like mine's like switch. It doesn't.
It doesn't matter. So you had 3x to the n plus 5 and then 2x to the n plus. Yeah. So guys, remember, these parentheses represent multiplication. Multiplication is commutative. So it doesn't matter which parentheses first. Okay, next one. How do I know that this is factorable? Charlie?
Because the exponent of the first one is double the exponent.
Exactly. The exponent of the first one is double the exponent of the second. So I'm going to use substitution. We're going to let we're going to let a equal x to the n plus 2, which means a squared is x to the 2n plus 4. So we have a squared plus 7a plus 12. And now we factor. This is nice. This is nice because it doesn't have a leading coefficient, so it's very straightforward. What are factors of positive 12 that add to a positive 7? 4 and 3. So plus 4, plus 3. Can I leave my answer like this? No, I have to sub back in. So this becomes x to the 2n plus 4. And, oh, no, sorry, that's not right. X to the n plus 2. And then x to the n plus 2 plus 3. So what have I added now? Another variable. Don't get frightened by the other variable. We're going to do this exactly as we've been doing it. We're just going to add in a y. And I'll show you how. There is no GCF. Because there's no GCF, we're going to factor with a leading coefficient. But this one's not as bad as other ones because this leading coefficient is prime. So I know the only things that add multiply to 2x squared is a 2x and an x. There's no other options there. Have I lost anybody? We okay? Okay. So now we want to multiply to a positive y squared, 5y squared. But when I multiply, I have to multiply to a positive 5y squared. But when I recheck it, I have to add to a negative 11. What does that tell us? If I'm multiplying to a positive, but then when I check, I have to add to a negative. Charlie?
The answer has 2 negatives.
Your answer has 2 negatives. Exactly. And this is also not so bad. Why is this also not so bad? 5 is a prime number. So now it's just about guessing the location. So I'm going to put, and now I'm not just multiplying to 5. What am I multiplying to? 5y squared. So I'm going to put a 5y here. I'm going to put a 5y here and a y here, right? Because negative 5y and a negative y is positive 5y squared. Now I'm going to check this. How do I check this again? The middle term. Who remembers how do we check the middle term? Only Ariana remembers? Same hands every time. Who remembers? How do I check this middle term? Okay, so you take your first number, first term, and you're going to multiply it with the last, including the sign. So 2x times a negative y is a negative 2xy. Then you take this one and multiply it with this one. Negative 5y times x is a negative 5xy. Is negative 2 and a negative 5 ever going to get us a negative 11? No. So that doesn't mean this can't be factored. What does this mean? Try to switch the locations. So I will put the y here and the 5y here, and we'll check again. So 2x times a negative 5y, isn't that a negative 10xy? And then negative y times x is a negative xy. Is negative 10xy minus xy a negative 11xy? Yes. So now we have our winners. So it becomes 2x minus y and x minus 5y.
This would be
You would do this with earmuffs the same way. You would just ignore the y and then add it in the parentheses at the end.
so you like at the end, just put
So with earmuffs, you would do, let's say we're pretending we're ignoring the y, right? So then you would do 2x squared minus 11xy plus 5y squared. So we would do what we normally do, 2 times 5, which is 10. And then you do factors of 10 that add to negative 11, which are, yep, negative 10 and a negative 1. And then we're going to divide by 2, x, and then simplify. So you would get an x minus 5. But because it was supposed to be y squared, you're going to put an x minus 5y because of this y squared at the end. And then we're going to have 2x minus 1y. So you just add in the y at the end. I think that would be how I would go about it. Okay, next one. What number is this? 5, 6. Is there a GCF? Yeah, what's our GCF? 4. Oh, wait, before I even do a GCF, this is factorable, right? Because I have one exponent double the other. Do you want to use substitution, or are we okay not using substitution here? Does anybody feel very strongly about using substitution? Okay, good. So if we don't use substitution, we're going to pull out that 4, and we're going to have x to the 4th minus 6x squared plus 5. So now when we come to factor, I'm not going to put in my parenthesis x and x. How come I'm not just going to put x and x? Because I can't multiply just to x squared. What do I need to multiply to? X to the 4th. So what is it going to be? X squared and x squared. Did I lose anybody with that? Okay, now I need factors of 5 that add to a negative 6. Factors of 5 that add to a negative 6. Jenky?
negative.
Negative 5 and a negative 1. Okay, great. You might think we're done, but I'm going to tell you we're not done. Does anybody know why we're not done? Karen? Good. The next step in this factoring is to never think you're done factoring. So now what you're going to do, if you have an exponent higher than 1, if in your final factoring you have an exponent higher than 1, you always have to look, can I factor this more? I can't factor x squared minus 5 because they're not perfect squares. Well, I can say the 5 is not a perfect square. But x squared minus 1, this is a difference of 2 squares. X squared is a perfect square, 1's a perfect square. What multiplies to 1? 1 and 1. So this becomes 4 times the quantity of x squared minus 5 times x plus 1, x minus 1. So I look one more time. Is there anything else that can be factored? No. So this is my factored form. Next one. Yes.
You're trying to solve for x. You want to didn't you want to convert if you're doing like, did you end up converting like the f it's 5 to like plus root 5, that's plus root 5 and
When you were solving,
yeah.
if you were solving, this would still be the factors, and then you would say x squared minus 5 equals 0. So x squared equals 5, and then x will equal plus or minus root 5, but the factor would still be x squared minus 5. So it wouldn't be the radical part of it. But we're not there yet. That's next chapter. Actually, that's not even next chapter. I think that might, is this maybe the end of this chapter? I don't know, but we're not there yet. All right, let's do another one. For some reason, this always throws everyone for a loop, and I'm not quite sure why. Don't let the variables frighten you. You two guys are so sneaky. I'm just gonna move your seat. What's your name in the middle? Vivette? Vivette? Okay, Vivette, where are you gonna sit? Vivette, you and Violet could switch. Violet, you're gonna come over here. Okay, so we're not going to feel intimidated by this problem. This is the same process. Don't we need factors of the last that add to the middle? It's really just that simple. What multiplies to mn? The m times n. Then you check. If I take those two factors and I add them, does it add to that middle term? Yeah. So this just becomes x plus m and an x plus n. That's it. All right. I think we're done for the day. You do have homework. I will post it on Classroom. It is textbook homework.